solving equations again today. It's only that now our problems are in context of some real world scenario. So when we get an answer for X or for T, it means something to us. Okay, so we're just going to look at a couple of examples, and you'll have some time to try some on your own, and what you get done in class will just be stuff you don't have to do for homework. Okay. Ooh. That was on transparent. We don't want that. So I would write this down in my notes so that you have like a context of like what things you were given and how we started these problems. Okay. This one's very similar to our warm-up. I'm going to do this one first because this one is the less nice of my two examples. So we'll get the ugly one out of the way first. It says you deposit $1,000 into an account. It pays 3.5% annual interest, compounded monthly. I'm going to ask two separate questions of you. My first question that I ask, what's the balance after 5 years? This is a question similar to the answer for the warm-up. So I'm thinking everyone can do this. You have a few things have been tweaked. The number of times we compound, the initial amount or our deposit, our principal. So I'm just going to give you some time right now. Write this out in its formula form and then plug that into your calculator. I'll walk around and see if you can get the correct answer. If I ask when, what do you want to find? The time, right? When implies time. So when it says, when is your balance 3,500, that means we don't know how many years that is. T is unknown to us. T will be left as a variable. But I'm going to give you another set of information that you need, which is like what balance I want. So I deposit 1,000. I'm going to let it sit in the account and earn interest. And I want to know, when will my balance be 3,500? I can plug that number in for what? Yeah. Will it be P? The principal, the amount I put in? Oh, it will be A, the amount in the account, right? The principal hasn't changed. I still am depositing $1,000. I just want to know when it will grow to be 3,500. So this gets plugged in for the big A, the amount in the account. Okay, so let's write that out. 3,500 is equal to 1,000 my principal times 1 plus 0.035 divided by 12. And then we would do 12 times T, which I don't know what T is. Now, here are some hints for making this solving process a little bit easier. We're kind of stuck with this 1 plus 0.035 divided by 12, but I feel like a lot of us would be a little bit happier as we continue to solve if that was just like a single number. So let's do the stuff in the parentheses in our calculators. Will you type that into your calculator? 1 plus 0.035 divided by 12. Do you need a pass back?
No.
Did you get a decimal that goes on and doesn't have a nice number? Okay. So what we're going to do here is, because this is so early in the problem and we still have a lot of solving left to do, we're actually going to keep a lot of numbers that come after the decimal. My recommendation to you, so you're not off by dollars, you're only off by maybe a few cents, is to use like 5 or 6 numbers after the decimal. So I know that's not also a very nice number, but at least it's better than having to keep writing 1 plus 0.035 divided by 12. So let's call that, I got 1.002916. If you round that right now to 1.003 and you use 1.003 for the rest of the problem, you'll probably be off by a few dollars. And to avoid that issue, you just need to have a few more numbers after the decimal. Okay, so is everybody okay with what I did right there? Okay, now we want to get into the actual solving stuff. So remember, the question is, when is your balance $3,500? So we're trying to find the value of t, but t is trapped up in the exponent. So if we think about solving from last week, our job is to get the exponent and its base all by itself. What will we have to do first? Divide by 1,000, Faith says. If there's ever an initial amount, and in most problems there is an initial amount, always divide the initial amount out first. Okay, so we're going to start by dividing by 1,000. And I'll make a little note over on the side. Always divide by initial amount first. We want to get the exponent and its base all by itself. So you should come up with something like 3.5 equals 1.002916 raised to the 12t. Now, you look at the exponent 12t, you look at the thing that it's touching, its base, 1.002916. Are they all by themselves? Yes, so remember back to last week, how do you solve exponential equations when you get the exponent and its base all by itself? You rewrite it as a log. So what's the opposite of an exponential equation? A logarithmic equation. We want to do the opposite operation here. Okay, so we're going to rewrite as a log. So I'm going to make a note right here, rewrite in log form. Now remember, to rewrite it in log form, you always have to start at the base, which is the base to the exponent. So our base for our log is going to be this long decimal, 1.002916. And we'll say the log base 1.002916 of 3.5. So we got to go around the equal sign. Equals, remember that the answer to the logarithm is always the exponent, so it equals 12t. And although that doesn't look incredibly nice, we are somewhat pleased because the t is now on the regular line of text, and I'll be able to solve by eventually dividing by 12. Is everybody okay up until this point? Okay, so now we're going to pull that other piece of information we learned in the last half of Chapter 6, which is how will we evaluate this log? Jackson? Yep. We're going to use change of base formula. So most of us have calculators that do not have a special button for logs of different bases. So most of us have to do log of 3.5 divided by log of 1.002916. Remember, the base is always in the bottom. That's the change of base formula. And that's how we can evaluate any log. Decimals, fractions, funny numbers, whatever. Don't forget that when you type that in your calculator, when you do the top log of 3.5, it'll open a parentheses. You got to make sure that you close the parentheses around 3.5 so you can get the right answer. I get for that 430.24. if you're kind of looking at the process of your equation, you're very near the end. The only other thing you have to do at this point is divide by 12. So I didn't put as many numbers after the decimal on this one because I don't need to know my years down to the nearest like 10,000ths place. Okay, so calling 430.24 to the nearest hundredth is probably fine. Okay. And then we still have to divide by 12. So how many years will it take for us to get $3,500 as our balance? 36 years. I think it's like 35.9. Good. So it takes a while, right? If you only have $1,000, it takes 30 plus years for you to make 2,500, but at the same time, if you think about it, you haven't really done any work to make that money. You've just kind of accrued it. And that's kind of the idea behind like putting money away for retirement. Okay. If you talk to your parents, they might have a retirement account and they put money in every month. So it's a little bit different than this scenario where like we just put money away one time. We put money away every month, every paycheck. Okay, a certain, couple $100. And then the earlier that you do that, if you start that in your early 20s, that money that you've been putting away every month just sits there and earns interest. And the idea is that when you decide to retire, you'll have more money, okay, because you've saved and you've put away a lot. Okay, so that's an interesting thing for you guys to think about. I know you're young and you're probably not thinking about retirement, but the recommendation is like if you go to college and then you get a job, like first job, start putting money away. Okay, I don't think it's really necessary. Someone asked me, I can't remember if it was in this class or another one, if high schoolers should be putting away money in retirement. I mean, I guess you could, but I also think like a high schooler might be saving for college or something like that, and that's going to be a good thing for you to invest in because you'll make more money if you go, most likely. Some jobs not. But something to think about, okay? Any questions on that problem that I can answer for you? We're going to do one other one, and then I'm going to give you some time to work on some on your own. So the next one I'm giving you is a little bit less heavy with numbers. Okay, so I would put this one in your notes so you have another example. This time, we're going to have your family purchase a new computer. Okay, it's a nice new computer. It's going to cost us $1,200. The value of the computer depreciates 30% each year. So first thing we want to do is create a model. Given this information, what model can we write to represent the value of the computer after T years? So I know how much is it worth after 1, 2, 5, or 10 years. Okay. This one is a little bit different. In this scenario, do I mention compounding at all? No. So those two compound formulas that I give you, we don't need to use either one of them. Okay. There was a third formula that we talked about. This was prior to our Skittles experiment at the very beginning of the chapter. Do you remember this formula? Y equals A times 1 plus or minus R raised to the T. I'll choose the minus R on this one because what's happening to the value of my computer? It's decreasing. Okay, so it's not going to be worth more than it was. It's going to be worth less than it was. And so all we have to do on this one to write the model is plug in for the A, which is the initial amount, and the R, which is our amount of decrease for the computer. Okay. I'm going to change, when I write my model, I'm going to change y to v to represent value, but you could certainly leave it as y. I like to change it to a letter that means something in the context of the problem. So my initial amount is 1,200, and then I'm going to do 1 minus, the rate of decrease is 30%, which will be 0.3, and then raised to the t. I would recommend that you start getting in the habit, if you're writing that model and inside that group of parentheses you have 1 minus 0.3, you could really write that as 0.7, okay? That will make it easier when you're solving to have that as one number. So I'm going to write my final answer as v equals 1,200 times 0.7 to the t. And there's my model. One thing I'll say for models, and we said this a long time ago, if you're writing a model t or whatever x you're using, should be left as a variable. Okay. If I ask for a model, there should be 2 variables, an x and a y. In this case, a t and a v. So that I could say, Faith, how much is the car worth in 2 years? Riley, how much is the car worth in 5 years? Or not car, computer, worth in 5 years. Justin, how much is the computer worth in 10 years? And they could each separately plug in their number for t. Okay. Now, I'm going to ask you this question. How much will the computer be worth after 1 year? What would you do to answer that question? Yeah, just multiply them together. Put 1 in for t, right? And then 0.7 to the first would just be 0.7. So the value of the computer is 1,200 times 0.7 to the first, which is just 1,200 times 0.7. What do you guys get in your calculators there? $840. So you bought it for $1,200, and 1 year later it's $400 less worth. Which I think we would probably agree, like, that's probably true with technology. It loses a lot of value right away because they come out with something new. Okay, so that's easy. When will the computer be worth only $300? How will you answer this question? Now you're going to do what? Put 300 in for V. Okay, when is the computer worth 300? 300 equals 1,200 times 0.7 to the t. I'll move my shade so I can get that a little higher for you. What would you do first to solve that equation? What's that? Yeah, divide by the initial amount. Remember, we can't rewrite it if the initial amount is still there because it doesn't have a place to go in a log. So we're going to divide by 1,200, which should give us 0.25 equals 0.7 to the t. Your exponent is t, your base is 0.7. Is it all by itself? Sure. So now we can rewrite it as a log. Start at the base. Log base 0.7 of 0.25 equals t. I got 2 decimals in my log, so I'm going to need to use my change of base formula. Okay. So I'll do log 0.25 divided by log 0.7. And what do you guys get for t? About...
I got 4, but I just found the whole number. Is that okay?
Yeah, I think it's 3.8.
Yeah, 3.8.
Yeah. In about 4 years, that $1,200 computer will be just worth $300. There'll be new and better things. Anybody have any questions? It's pretty straightforward. What will be interesting